This video is brought to you by MathGalaxy.com, and here we'll be reviewing percent problems, which there are about 2 to 3 per test, including percent of problems, percent increase, decrease, and decimal and fractions, 2%, and pie charts. You can find problems to practice these in the 10 practice tests in the College Board's official SAT study guide. The notation here is that this is Section 3, Problem 5 in Practice Test 1. There are 2 forms of the percent relationships that you should know. First is the part over whole format. We're just saying a part is what fraction of the whole converted to a fraction out of 100. For example, saying 5 is what percent of 10. So another way of interpreting it is to of. 5 is what percent of 10. So you can solve this by cross multiplication. 10x is equal to 500 divided by 10. So this would be 50%. The second form is percent over 100 times the whole is equal to the part. And that's useful if you're taking a percent of something. So if you were saying 50%, so 100 in the denominator means percent. So you can have one or the other, but not both together. So 50% of 10 is equal to 1/10 of 50, or 5. For percent increase, the increase is the part and the starting amount is always the whole. So here, if something goes from 8 to 24, the part isn't 24, it's the increase. So you're saying, what is the increase relative to the starting point converted to a percentage basis? And you can reduce this to 2 over 1. And cross multiplication, x is equal to 200. And 200 over 100 is 200%. And for decrease, the part is the amount of decrease, not the new amount. So 10 minus 2 is 8, and the starting amount is always the whole, is equal to x over 100. Cross multiplication, or you could do it by equivalent fractions, because this is just another form of proportion. So by equivalent fractions, the multiple there is 10, so the multiple there is 10. So x is equal to 80, and 80 over 100 is 80%. Okay, and a particularly tricky problem is if you're trying to find the whole. It's like if something goes down 25% to 12, what was the whole? Okay, well, the percent is not 25%. 12 is not 25% of the original amount. It's what's left after you take 25% away. So here the part is 12. We're looking for the whole. And 12 is 75% of some original amount. So again, by cross multiplication, we have 75. W is equal to 1200 And dividing both sides by 75, we get W is equal to 16. So that's a quick review of the main rules for percents. Now for some practice problems. If you want to try this on your own, you can pause the screen now. Whenever you can, you want to start from the basic rule. So here, if we started in terms of the is to of, part is to whole, as percent is to 100. So if you know two of the three, you can solve for the third. So A plus B. So the part will be next to is. It's a plus B is 125% of 4B. Or you say 125% of 4B is A plus B. So in this form, it'll be next to is, either before or after. So we have A plus B, and the of part is our whole, so that's 4B, and so the percent sign is equivalent to 100 in the denominator. So now cross multiplication, that gives us 500B is equal to 100 times that. So 100A plus 100B. So, and our target is to get A over B. So we have two unknowns. We can't solve for them individually, but we can get their ratio. Subtracting 100B from both sides, we get 400B is equal to 100A. So if we want to get A over B, well, first we could divide by 100, so we get A is equal to 4B. So we're a little closer to what we want. We want this to look like A over B. How do we make this look like that? We'll divide by B on both sides. So that gives us A over B is equal to 4. Next problems. If you want to try these on your own, you can pause the screen now. First one, if a box contains red, blue, and green marbles, and a fourth are red, a third are blue, and 10 are green, how many marbles are in the box? So it's a good idea to start with a diagram. For part-whole problems, you can represent the parts either as fractions or as percents. If you do it as fractions, they have to add to one whole. If you do it with percents, they have to add to 100%. So here, a fourth are red, a third are blue, and 10 are green. And to solve for the whole, you need two pieces of information for a given part. Here we only have one for each. But the key is that parts have to add to 1. So 1/4 is 3/12. 1/3 is 4/12 for a total of 7/12. So the green have to be 5/12 of the whole. So now we have enough to get the whole. So 5/12 of the total number of marbles has to equal to 10. And to get W by itself, multiply by the inverse here, 12 over 5. So those cancels. So we multiply this by 12 over 5. 5 goes into 10 twice. 2 times 12 is 24. And you could also have done it as equivalent fractions. So for every 12, 5 are green. And since there are 10 green, then to get the total number, we just do, well, cross multiplication or by equivalent fractions. That multiple there is 2, so the multiple there has to be 2. So W has to be 24. Next problem. If you want to try this on your own, you can pause the screen now. If a box contains red, blue, and green marbles, and a fourth are red, 12 are blue, and 55% are green, how many are red? So again, it's a good idea to draw a diagram to represent the whole and put what information you know on it. So a quarter are red, 12 are blue, and 55% are green. And asks how many are red. So here again, to solve for any information, you need 2 pieces of information for a given part. So here we could do this as a percent problem where they have to add to 100. So these two add to 80%. So the blue has to be 20% of the whole. So now we have 2 pieces of information. So 12 is 20% of the total number of marbles. So using part over whole is equal to percent over 100 form. 20 W is equal to 1200 by cross multiplication. We can divide by 10 and then divide by 2. The whole is equal to 60. But you always want to take an extra second to make sure you're giving them exactly what they want. They don't want the total number of marbles, they want the number that are red. So a fourth of that, you can just divide by 4, that will give you 15. Or you could have set it up as a part over whole form. Next problem. If you want to try this on your own, you can pause the screen now. If Jane's monthly expenses are as shown and she spends $200 a month on food, how much does she spend on transportation? Well, what do we need to know to find what she spends on transportation? It's 15% of monthly expenses, but we don't know monthly expenses. But we know that this 20% accounts for $200. So we have a part of the whole with 2 pieces of information. So we can, from there, saying 200 is 20 hundredths of the whole, 20%. And cross multiplication, 20W is equal to 2 with 4 zeros. You can divide by 10, then divide by 2. Whole is equal to 1,000. And if we did 15% of that, so X for 1,000, go 15 over 100. So, well, this is 10 times that, so that is 10 times that, so X is going to be 150. And another way of doing something like this is just as a proportion. So you could say for food, $200 is 20%. And so 15% is X dollars. So you can save a couple steps here. So 200 times 15 is 3,000 is equal to 20x divided by 10, and then divide by 2. X is equal to 150. So that is sort of a shortcut. Next is a percent of percent problem. If you want to try this on your own, you can pause the screen now. So for a problem like this, this is probably the best way to do it. Percent times the whole is equal to the part. And we're just doing it twice. So 1/2 is equal to 0.5. Percent is 100 in the denominator. Of means times. So, and then we have 0.8 over 100. So let's use an x here. And of 600. Okay, so that 100 goes into that 6 times. So 0.5 times 0.8 is 0.4 over 100 times 6, which is equal to 2.4 divided by 100. And divided by 100 is 2 decimal places, so it's 0.024. Next are percent increase and decrease problems. If you want to try this on your own, you can pause the screen now. If the price of widgets goes from $20 to $24, what is the percent increase? It always helps to draw pictures or diagrams, and I like to use boxes for these type problems. So it goes from 20 to 24. Wants a percent increase. Well, for a percent increase, you want to be thinking of, you want to know what is the increase converted to a percentage basis. The increase relative to the starting amount is always the whole, converted to a percentage basis. So we can call that x. So 20x is equal to 400 divided by 20, x is equal to 20. And 20 over 100 is equal to 20%. Next problem. If you want to try this on your own, you can pause the screen now. If a store's January sales were 10,000 and its February sales were 2,000, what was the percent decrease? So again, it helps to draw a diagram. We went from 10,000 to 2,000. So you're looking for the decrease relative to the starting point converted to a percentage basis. Okay, so for percent decrease, it's not the new amount, it's the amount of decrease, which is a subtraction problem. So that's 8,000 from a starting point of 10,000. So we can call that x, and these are just like fractions, so we can reduce that sum. So 10x is equal to 8 times 100, or 800, divided by 10, x is equal to 80. And 80 over 100 is 80%. Next problem. If you want to try this on your own, you can pause the screen now. If you receive an additional 20% discount on an item already marked down 50%, What was the final discount as a percent of the original price? When you're dealing with relative amounts, you can work with specific numbers. So here, since it's a percent problem, why not start with $100? And if it's reduced 50%, then that price is $50. And you get a 20% reduction on the $50. It's not 20% of the original amount. And if you use the 10% rule, which is 1/10 or 1 decimal point, 10% would be 5, so 20% would be 10. So that's another 10 off. So the final price is 40. And in terms of the original price, then that's a reduction of $60 or 60%. So when stores give you discounts in this form, you think you're getting a 70% discount, but you're really not. Next problem. If you want to try this on your own, you can pause the screen now. If a price decreases 20% and is now $12, what was the original price? And it always helps to draw a diagram. And I like to use these boxes. So it went down 20%, and it is now $12. So we're looking for the original amount. And remember, for any part, you have to have 2 pieces of information for that part, particularly to find the whole. So 12 is not 20% of the whole. This is 20%, but 12 is this part, which is 80% of the original whole. So that's the percent that you need, and that's where you need to be careful. So 12 is what part of the whole? Oh, it's 80/100ths of the whole. So this is the part, that's the whole. So we can reduce this. So we get 8W is equal to 120 divided by 8, and W is equal to 15. Next problem. If you want to try this on your own, you can pause the screen now. So fraction problem, 0.8 over 0.05 is equivalent to which of the following? With fractions like this, you don't want to mess time with common denominators or anything else. Just turn everything into a decimal. Divide 0.8 by 0.05, you'll get 16. So depend on your calculator. Divide 3 by 8, it gives you 0.375. B gives you 1.6. C gives you 0.8. D gives you 16. So if you've done your calculation right, that's the answer. If you want it to be sure, you can do the last one also. Next problem. If you want to try this on your own, you can pause the screen now. A cup is filled 1/3 full with orange juice. It is then filled to the top with equal amounts of orange, apple, and grapefruit juice. What fraction of the final mixture is orange juice? With part-whole problems, it helps to draw something to represent the whole. So 1/3 is orange juice. Let's see, that 1/3 is orange juice. And then it's filled to top with equal amounts of apple, orange apple, and grapefruit juice. So it means 1/3 what's left is divided into thirds. Okay, so what's left? So we have orange juice, apple, and grapefruit juice. Okay, so what's left? Well, that's 2/3 of the original, and this is 1/3 of that 2/3. So this is 1/3, and of means multiplication of that 2/3, which is equal to 2/9, and this 1/3 is equal to 3/9. So orange juice is 5/9 of the entire amount. Next problem. If you want to try this on your own, you can pause the screen now. Here, x is 1/2 of y and y is 1/3 of z. What fraction of z is x? When you're dealing with relative amounts, like ratios, you can work with specific numbers. Here, x depends upon y and y depends upon z, so you would want to choose z first. Let's say 30. So 1/3 of z is 10, so that's y. And x is 1/2 of y, so x is 5. So what fraction of z is x? It's 5/30ths. And if this were a grid in, you could grid it in like this, or reduce it to 1/6. The algebraic solution would be do it by substitution. So y is equal to 1/3 of z, and x is equal to 1/2 of y, and then substitute for y. X is equal to 1/2 of 1/3 z, or 1/6 z. Next problem. If you want to try this on your own, you can pause the screen now. X is 1/5. What is 1 over x squared plus 1 over x minus 1? With fraction problems, the best way to deal with them is to convert everything to decimals. So this is 0.2, so it's 1 over 0.2 squared plus 1 over 0.2 minus 1, which is 1 over 0.04. So you want to depend on your calculator, plus 1 over minus 0.8. So if you do this division, you get 25. That becomes a minus, and 1 divided by 0.8 is 1.25. And that gives us 23.75. That's the end of our review of percent fraction and part whole problems. But you can't really master the concepts without practice. You can find practice problems in the College Board's official SAT study guide, the Blue Book. In their 10 practice tests, these are problems related to those concepts. For example, this is Section 3, Problem 5 in Practice Test 1. So good luck with the test.